From CBC Television in Saskatoon, this is Saskatoon Today with Eric Forbes.
It's good to have you with us this day. Now, it's spring when a young person's fancy turns to thoughts of love and cars. Now, if you've only been thinking of cars, we've got a show for you. We're going to look at a car of the future that was built right here in Saskatoon. Engineering students at the University of Saskatchewan are world leaders with experimental gas-saving cars. Cars that could go to Florida on about $2 worth of gas. Now, if you've seen them, you know they're too impractical, too flimsy. But the engineering students have found a way to make wonderful use of this gas-saving economy.
It's called the Nexus. It's very cheap and safe to operate. The Nexus is a sleek, single-passenger vehicle on 3 wheels that may become the commuter car of the future. It's been developed with the advice and under the direction of Dr. Barry Hertz.
When did this project start?
In actual fact, work on this type of vehicle started back in about 1981 when we had a group of fourth-year students do a design exercise on a car we called the NBB vehicle. For 3 students, Nilsson, Blazik, and Blazik, the 2 Blazik brothers, did a design of a commuter vehicle quite similar to this that was motorcycle safety compliant. And after submitting these proposals to Transport Canada, they decided that this type of vehicle, although very fuel efficient, should be a lot safer. Since, I don't know if you're aware of this, but in the United States, any 3-wheel vehicle is still just considered a motorcycle, and so it doesn't have to have any crashworthiness aspects built into it. So the federal government decided that it would be a good idea to investigate vehicles of this type that would be more crashworthy, and that's how the Nexus project got started. The first student to work on it was Dave Gerwing, who graduated back in 1981, and he did his master's on the preliminary design of this Nexus vehicle in over the years 83, 84, and 85.
I think one of the things in design that's always difficult to accept that is, I guess, in order to really achieve any good design, you have to fail. And one way to achieve better designs, better and better designs, is to sort of double your failure rate, if you like.
And then we've had Rob McEachern, another graduate student, work on the crashworthiness of the car.
It's a quarter-scale tester. What that means is I only need 1/4 of the velocity, which is much easier to achieve than full velocity. I have a 1/4 scale model, and I have 1/4 of the mass of the car. So the hammer only weighs about 200 pounds, and it only travels at about 8 miles an hour when it strikes the plate. So in a sense, essentially it's just a swing with a big weight on it. The idea is for it to completely destroy itself and absorb energy. If this car was ever going to be certified for sale, they would have to test full-scale models, actually build full-size prototypes and collide them with a brick wall.
And currently, one of our own graduates, Robert Johnson from Carlisle, has just finished a master's thesis on the energy analysis of the Nexus car.
This is an exotic car, and it's an exotic project. You know, you're a long way away from the automotive industry. Is that anything of a problem for you people?
Well, it was interesting. We've just returned from a large congress down in Detroit where they had 35,000 automotive engineers, of which we have a student section here, the Society of Automotive Engineers. It was very interesting and encouraging to see their reaction to this car as it was on display there for a week. There was extreme interest and support shown by the automotive industry. And we do get all their publications and attend many of their large meetings. And so in that way, even though we're quite removed from the center of manufacturing, we still can play a real active role in the research aspect of automobiles right here at the University of Saskatchewan.
How has Transport Canada responded to it?
They've been quite pleased with the whole project. They were telling me how in France, for example, they've had a project something like this in the works, and there the expense in the development of a car to this stage has been more than 10 times more costly than the Nexus project has for us. And so they were quite pleased with the design of the car and the performance of it, and they're continuing to support it for at least 2 more years.
It would seem to me that it would take a cultural leap before we're ready for a one-passenger vehicle. Why have you not developed a 2-passenger or 3 or 4-passenger vehicle?
Basically, I guess the reason is because those vehicles exist now, and in a government research project, you don't want to appear to be conflicting or competing with what they're already working on. And so the one-passenger aspect is quite important in that 80% of the time studies have shown that only the driver occupies the large cars we see on the road today. So they feel that they should be looking ahead rather than behind in terms of the research. And we feel that by the 1990s, vehicles of this type with 3 wheels and with 1 or possibly 2 people, but in tandem seating arrangement rather than side by side, will become quite popular.
What are the major safety features on the vehicle?
Well, this car, first of all, most vehicles are equipped with a 5-mile-an-hour bumper, which means you can run into a wall at 5 miles an hour and there should be almost no damage. This car is equipped with a 30-mile-per-hour bumper. The entire front meter of the car is crushable foam, and it's designed to compress on impact with minimal expense. It's a throwaway nose. It's replaced after a fairly severe impact that's a direct hit. And the remainder of the car, including the driver, should remain virtually intact. And so that's one of the big features. Also, its structural frame is at bumper height. All around the side of the car, there's a fairly stiff and strong aluminum beam, which would prevent intrusion in the event that you got run into laterally, like a T-bone collision in an automobile accident. And the vehicle is equipped with roll bars inside of the aerodynamic shell. And so these features, along with other things like the normal lighting and so on, make the car approach passenger car safety standards.
It's certainly a small vehicle, Barry. I was just wondering how cheaply one can operate this vehicle.
Well, this particular prototype is built with one of the largest engines that we studied. We studied 4 different possible powertrains for this vehicle. And with a 250cc motor, it's got a 90-mile-per-hour top speed. But even at that, when you slow down on the highway, you can get over 175 miles per imperial gallon, or about 1.6 liters per 100 kilometers, which is more than probably 3 times better than the best small cars on the road today.
We'll have more on the Nexus in a moment.
There has to be sort of a quantum leap in the cultural life of North America, I think, before people are going to leave their spacious cabins in their cars and move to something as compact as this. How about you? Do you think that too?
I think so, but I think the culture will be really motivated by the price of fuel. If we were paying, say, $3 a liter for fuel today, there'd be a real big demand for very fuel-efficient vehicles, of which this is one. At the current low price and without any tax on our fuel, there's very little incentive or need to conserve energy. And so right at the present time, we've sort of got a breathing spell to do the homework on what to do in the future when the next big energy crunch actually hits.
Let's assume that the vehicle has gone to production. How much would it cost?
This particular vehicle, being a research prototype, wasn't designed with the intent of mass production at all. But I would think that, in an automated assembly line, vehicles of this type could be built for under $10,000. but the investment to do that would be in the billions. And so that's one of the problems. You have to actually have a clientele ready to receive a vehicle of this type. And from the reactions we've had from the Japanese and General Motors and Ford and some of the other companies, they're looking at vehicles of this type. And this is one of the things to sort of urge them on to be ready for the scenario of very limited fuel supplies. And vehicles like this, under that sort of a environment, would be very, very popular.
If I may add to what FDR, Franklin Delano Roosevelt, once said, a chicken in every pot and maybe a Nexus in every backyard. Our thanks to Barry Hertz and his students at the University of Saskatchewan and the nice people at the Audio Visual Services at the U of S. Thanks for being with us this day. Take care. We'll see you next week.